Electronic configuration. As we move down the first group, we can see the electronic configuration of 1s block element. Let us take the first element, that is lithium. The atomic number of lithium is 3. So lithium has atomic number 3. It has the electronic configuration of 1s2, 2s1. 1s2 means that is helium atom. It's a noble gas electronic configuration. Helium is a noble gas. So 1s2, instead of 1s2, we can write helium's electronic configuration and 2s1. The next element found in the 1s block element is sodium. Sodium's atomic number is 11. See, the electron distribution is given like this: 1s2, 2s2, 2p6, 3s1. See, up to 2p6, we can take an inert gas, neon. Number of electron in neon is 10. So, up to 2p6, look at this module, up to 2p6, there are 10 electrons are there. Then you can write, instead of 1s2, 2s2, 2p6, you can write neon's electronic configuration in bracket, then 3s1. Similarly, potassium's, whose atomic number is 19, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So, up to 3p6, there are 18 electrons are there. So, 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18. So, the inactive gas or the inert gas with 18 electronic configuration is argon. Instead of writing up to 3p6, we can write argon in bracket and 4s1. Up to this potassium, we can see the valence orbital, there are s1 electronic configuration. That's why these elements are called as what? 1s block element. See, here in this module, you could see the electronic arrangement of a sodium atom. So, sodium contains 11 electrons. The first orbital, you could see 2 electrons around the nucleus. The yellow color ball is the nucleus. Green color small balls are electron. Okay. So, in the first orbital, that is 1s orbital, there are 2 electrons. Then the second orbital, there are 8 electrons. Okay. Next, the third orbital, there is only 1 electron is revolving. See, as I told you, this atom is electrically neutral in nature. That means in the nucleus there are 11 protons are there. Means equal number of electrons are revolving around the nucleus. That is why an atom is said to be electrically neutral. If the valence electron, that is the 3s1 electron, is lost, means simply it cannot be removed. We have to give energy. That energy is called as what? Ionization energy. So we could see the formation of a monopositive ion or a univalent ion. See, plus 1 is written as the superscript of this atom. Okay, in the square bracket, you can see plus 1. That means there is 1 proton is excess. When you compare the number of electrons, sodium, the electrons and the protons. Okay, when you compare the number of electrons and protons, 1 proton is excess. That's why it is denoted as plus 1. Now this is not an atom. This is called as what? Ion. A unipositive ion or a monovalent ion. Sodium ion, Na plus ion, is formed in this module. See, let us study the periodic properties of first block element, that is group 1 element. You can see in this module the atomic size of these elements are gradually increasing. See, lithium small size, sodium is little bit, the size of sodium is increases little bit, then potassium and rubidium, cesium and francium. Why there is a increasing in the atomic size? Because of their common oxidation state is +1. Okay, the common oxidation state of alkali metal is +1. Then let us see the ionic size and atomic radii. Atomic and ionic radii. See, along the group, when you come from top to bottom, the size gradually increases. This is because of addition of extra cells into the atom. The size of an atom increases. See, you can see increase in atomic radii from lithium to francium. As the number of electron increases, what happens? The size of an atom increases. Next, let us study about ionization enthalpy. See, what is ionization enthalpy? The energy required to remove the most loosely bounded electron in a valence shell is called as what? Ionization enthalpy. Here for this alkali metal, they have low ionization enthalpy. The first reason to gain a low ionization enthalpy is because these elements have a tendency to attain a stable electronic configuration. That is, the valence shell, they want to possess 8 electron. That's why easily they can lose one of its electron that is found in the valence shell. The second reason, on moving down the group, you can see the ionization enthalpy decreases. Why? Because the addition of number of inner shells increases along the group. Okay, as we have seen, the number of shells added, that's why the atom size increases. If the size of the atom increases, means the magnitude of screening effect. What is screening effect? The electron which is found in the inner shells repels the electron which is found in the valence shell. Okay, so if number of electrons are increases, the electrostatic force of attraction, that is the force between the nucleus and the valence electron, decreases. This is because of screening effect. Okay, then these are some of the reasons which is experienced by the bonus block elements down the group. That's why they have low ionization energy. Regarding the second ionization enthalpy, what is second ionization enthalpy? So it is very easy to make an ion from an atom. That means an electron can be removed easily from an atom. But from a unipositive ion, it is very hard to remove one electron. Okay, so the removal of electron in a unipositive ion is very hard process. That's why the second ionization energy in this 1s block is increases. One more reason is already this unipositive ions attains a stable electronic configuration. So it is very difficult to remove an electron from its valence shell. Right? That's why the second ionization energy of this S block elements increases, whereas the first ionization energy of this S block element decreases. See, the next periodic trend is the atomic size in periodic trend is the next periodic trend is across the across the period, the atomic size gradually decreases. You can see in this module, lithium has the bigger size, whereas helium is smaller in size. This is because of the electrons are entering in the same valence shell, so they have a compact structure. The size decreases across the period.